first, before you continue the video, to look at the solution steps, and we'll go through these answers together. In part 8, we have a function that's already separated into two big groups over here. And once we have this format, we're just looking at what common factor do these two groups share in common. And here we can see x plus 1 and x plus 1 are what they have in common. With this in mind, we can say f of x is equal to, we can factor out that x plus 1 and think about what's left. And from the first group, we're left with 3x, and the second group, I'm left with a plus 7 over here. And this is already in fully factored form. To find the horizontal intercept, I'm just going to set the function equal to 0 again, and based on the zero product principle, we can say x plus 1 equals 0, or 3x plus 7 equals 0. Therefore, x is equal to negative 1, or 3x is equal to negative 7, or x is equal to negative 7 over 3. Therefore, we can say the intercepts are these 2 points, negative 1, 0, and negative 7/3, 0. Now moving on to part B, we don't have the factored grouping for us quite yet. So what we want to do is to group things together. We're grouping the first two terms together and second two terms together into two groups connected by addition. And as we do this, we want to look at in each group, what do they have in common as a GCF we can take out. In the first group, we can see we don't have any constant term in common, and for the variable part, we have x squared being the lowest degree of x that they both share. So I'm going to factor that out. And that leaves me with x minus 2 over here. Now for the second group, we want to see for 5x minus 10, what do we have in common? And they have a common factor of 5. And nothing in common for variable, because negative 10 is a constant term, there's no variable in it. Once we do this, we'll see we are left with x minus 2 in the parentheses as a factor. And once we get to this form, this again becomes similar to what we started with in part 8. And then we just want to pick out what these two groups share in common. And they both share that factor of x minus 2. And that becomes our new common factor that we can factor out. Once we factor out the x minus 2, the first group we're left with x squared. Then the second group, I'm left with positive 5. Based on this, that's what we have left over, and we want to set that to be equal to 0 in order to find the horizontal intercept. And to do this, using the zero product principle, I know either x minus 2 is equal to 0 or x squared plus 5 is equal to 0. And for x minus 2 equals 0, we can solve pretty quickly. X is equal to 2. And for x squared plus 5 equal to 0, if you don't see this right away, I want you to think about what type of solution we can have. This is again a quadratic equation, and we haven't gone in depth in terms of solving all types of quadratic equation. You might be thinking about quadratic formula or things like that. But for this one in particular, you can see if we have x squared plus 5, think about the values x squared can take. We say if we square a number, we should get a non-negative number. And if we add 5 to it, we should expect to get a positive number. So no matter what x squared value is going to be, we should expect x squared plus 5 to be greater than 0. And in this case, we're wanting it to be equal to 0, and that could never happen. And the other way to think about it is if you had this case, you would have got x squared is equal to negative 5. And we know that if we square any real number, we won't get a negative value as a result. It just doesn't happen because all the negative signs would cancel each other out, and we would end up having a positive value if we're squaring any real number. And therefore, for this part, we would say there is no solution for this x squared plus 5 equals 0. And we're left with only one solution, one option, based on the zero product principle. Therefore, based on our only solution, we can say our horizontal intercept is a point 2, 0 as a result. And now for part C, if we look at h of x, we want to think about what we can do for factor by grouping again. Again, because there are 4 terms, naturally we can group the first 2 together and last 2 together over here, connect it by addition in the middle. And for the first group, we want to check and see whether we have anything common, and we can see we don't really share anything between x cubed and -9. So I'm just going to leave it as is. And then for the second group, when we look at -8x cubed plus 72, we can factor out a common factor of -8. Again, I like to take out the negative sign in a leading term just so I don't have to deal with it later. And as I do this, I'm going to be left with x cubed minus 9 again from the second group. And once we have this form, we can think about, we really have the 2 groups share this factor of x cubed minus 9. And because of this, I can factor out x cubed minus 9 as my common factor between the 2 groups. We would have got x cubed minus 9, and now if we look at the first group, the only thing I have left would be a factor of 1 to hold its place, because I took out exactly that term as a factor. And then for the second term, I'm left with -8. You can do plus -8 or just -8. And as a result, we can see that we really get x cubed minus 9 times -7. Using the zero product principle, if I set this to be equal to 0, we know -7 cannot be 0, so I'm only left with the option of x cubed minus 9 is equal to 0. And because of this, we can think about how we can solve it. One way to work with this type of problem is we can just let x cubed equal to 9 and take the cube root of both sides, and therefore x is equal to cube root of 9. And it doesn't end up being an integer, so it's okay to just leave it as cube root of 9 as is without worrying too much about the exact the values over here, or simplifying the values over here. This is the exact value. And we get the horizontal intercept is cube root 9, 0. And that's going to be our result for the horizontal intercept.